Hello friends, hope you people are doing good. Right, today we are supposed to study PRISM, which is subtopic of ray optics. Basically, in PRISM, we need to understand two more topics. First, that is refraction by prism, and other is dispersion by prism. But in this lecture, in this first video lecture, I am going to say all about this refraction by prism. First of all, you must know what refraction is. Then I am going to explain what prism is. See, in refraction, wherever the light enters from one medium to another medium, whether it is rarer to denser or denser to rarer, light is supposed to change its direction as well as speed due to the refractive index of medium. Right? In refraction, Snell's law must be followed, which is n1 sin I and n2 sin R. Here n1 is refractive index of medium 1 and this is for medium 2. Right? I is angle of incidence and R is angle of refraction. Okay, when light is entering from one medium to another medium, say n1 is greater, say n1 is less than n2. Okay, this is the interface which differentiate medium 1 and 2. When light enters from one medium to another medium, obviously the path is supposed to change either towards normal or away from the normal. As it is moving from rarer to denser, the light ray is moving towards the normal. But when it comes out from the medium, it will move away from the normal. These are the basic things about refraction. In prism, same thing we need to follow. Right? Prism is basically made up of glass. Generally, we take refractive index of glass as 1.5. See, the shape of prism, if you see the prism exactly from front side, the front view of prism is triangle, but it is not a triangle. Right? Three surfaces, 1, 2, 3, this 1, 2 and 3. These three surfaces are in rectangular form, but this surface is kind of a triangle. So this kind of two surfaces are there. The front view of the prism is triangle. Let us understand refraction in prism. The most important thing about this topic is the diagram. Right? Please be focused in the diagram so it will be easier for you. See this. Oh, sorry. This is the prism, the front view of the prism. This angle is called prism angle, or you can say angle of prism. This you can say surface 1 and surface 2. Okay, medium, outer medium, say n1. N1 is air, n2 is glass. Obviously n2 is greater than n1. This is the incident ray to the surface. Always consider whether it is reflection or refraction. We need to focus on those angles which are made up with the normal to the surface. So this is a normal 1 at surface 1. Normal is always making an angle of 90, that's why it is called normal. When the light ray is moving from rarer medium to denser medium, here n2 is greater than n1, rarer to denser, right? Definitely it is moving towards the normal, like this. This was the actual direction of light ray. If the prism was not there, the light ray could move in this direction. Now it is moving towards the normal. So this angle is delta 1, deviation at surface 1. According to Snell's law, this angle is I, this angle is R1. at surface 1, Snell's law is n1 sine I is n2 sine r1. Here I and r. I is angle of incidence and r1 is angle of refraction at surface 1. These two are at the rate surface 1. Okay. Now see this. This ray is called incident ray. This ray is called refracted ray. So RR. Suppose the N2 is extended up to infinite. So this could be the direction of light ray, refracted ray. But it's not like that. Now the refracted ray will become incident ray for surface 2. And as it is coming out from surface 2, it means it is moving from denser to rarer. Let me draw a normal at this surface. Normal 2 at surface 2. This point say L. Now the light ray is moving away from the normal. This ray is called emergent ray. You can say ER. Okay. Say this. This point is named as M, N. This was the actual direction of refracted ray. But now the light ray is moving away from the normal. So this is emergent ray. You can say this is deviation at surface 2, delta 2. Okay. Let me extend this thing, this line. So as this is delta 2 also. Delta 2, delta 2. Vertically opposite angles, right? Now, as surface 1, same as surface 2. At surface 2, let us say refracted ray is making an angle of R2 with normal 2. So, at surface 2, N2 sine R2 is equals to N1 sine. This whole angle is named as E. E is called emergent angle. E is emergent angle. Okay, right? N2 sine R2 is equals to N1 sine E, where R2 is incident, or you can say angle of incidence. Angle of incidence at the rate surface 2, and same E is angle of refraction at surface 2, or you can say this is emergent angle. Okay, this is the basic characteristic of prism when the light ray enters from rarer to denser and getting out from denser to rarer. So at surface 1, N1 sine I is equals to N2 sine R1. At surface 2, N2 sine R2 is equals to N1 sine E. The basic thing related to this topic is the diagram. The most important thing is the diagram. You must know how the light ray enters from one to other medium, one to second, second to first, right? So now we need to derive the relation between I, E and this delta. Now what is this delta? Delta is called total angle of deviation. Delta is total angle of deviation by prism, or angle of deviation by prism. Right, what is this angle of deviation? Delta 1 is deviation at surface 1, delta 2 is at surface 2, delta 1 plus delta 2 would be delta. This delta would be delta 1 plus delta 2. Why so? Just focus on this triangle. Okay, delta 1 and delta 2 are interior angles, and delta is the exterior angle. So if this is 30, this is 40, then this must be 70. Okay, right? I need to draw the whole diagram again just to explain or just to derive the relation between I, E and this delta. And most important thing, angle of prism. As I told you, the diagram is important. See this. A prism angle, normal at surface 1. So this is incident ray, angle of incidence I. Now the light ray is moving from rarer to denser. This is normal 2, okay, and this is emergent ray, ER, IR, RR, incident ray, refracted ray, emergent ray, I, E, this one is R1, this one is R2, so this is L, M, N. This is the actual direction of light ray. So this angle is delta, okay. This angle is delta 1, this angle is delta 2. You can say this whole angle is delta. Now see this vertically opposite angles where two lines intersecting each other. So this angle and this angle must be same where they are generating a cross. So I is sum of delta 1 and R1. That I is delta 1 plus R1. Same way E. This E is sum of delta 2 plus R2. Okay, we are going to use these equations. I is angle of incidence, E is angle of emergent. Now, say this point is D. Okay, so this point is D, where the angle of deviation occurs. Now, focus on this triangle DMN. From triangle DMN, I can say delta is delta 1 plus delta 2. Now, MLN for triangle MNL. See this again, MLN, R1 plus R2 plus L. R1 plus R2 plus L is 180. Therefore, R1 plus R2 is 180 minus L. Okay. Which triangle it is? The triangle is, this point was M, N, L. R1, R2. Okay. This is normal too. Now, for a quadrilateral, A, M, L, N. See, in a quadrilateral, all four angles, sum of all four angles is 360. Let me draw the quadrilateral. These are the normals. A, M, N, L. M and L are 90 degrees. So sum of A and L is 180. Here A plus L is 180. Therefore, A is equals to 180 minus L. Say this R1 plus R2, equation 1, equation 2. Right, R1 plus R2 is equals to 180 minus L is equation 1. And A is equals to 180 minus L is equation 2. From both the equation we can clearly see this. R1 plus R2 is A. Right now we are deriving the relation between I, E, A and delta. Here, say this, R1 plus R2 is A. Delta 1, where is this? Delta 1 plus delta 2 is delta. Let's say this equation is A, this equation is B. From equation A and B, delta 1 plus delta 2 is delta, R1 plus R2 is A. Adding these two, R1 plus delta 1 and R2 plus delta 2 is delta plus A. Just look at this. Delta 1 plus R1 is I. Delta 2 plus R2 is E. This could be written as I. This can be written as E. Delta plus A. So finally, we have derived the relation between I, E, delta and A. One more thing which clearly says that A is a constant as it is a prism angle. So if you are supposed to change I, then E is going to be changed as well as delta. So the graph which is showing the relation between I, E and delta, right, that we are going to study in our next lecture, part 2, prism, right. For today, up to this lecture, we keeping our solution up to this. Thank you.